Solving a system of linear equations using elimination with addition. The goal in these problems is to cancel either the variable x or the variable y when combining the two. Currently, negative 4x combined with 5x add up to positive 1x. Positive y combined with a positive y add up to positive 2y. Neither becomes 0 at the moment. We need to rewrite these equations so that either the x terms or the y terms add up to 0. If we look at the y terms, they both have a 1. All we need to do in this case is make one of them opposite of the other. In other words, change one to a negative or subtraction so that they will add up to 0. We can change either of the two. I'll just go with the second here. We're going to multiply everything in this equation by a negative 1. We'll go ahead and rewrite the new equations over here to the right side. The first equation, again, is unchanged. We will keep that as negative 4x plus y equal to 13. The new equation for the bottom would be negative 1 times 5x, resulting in negative 5x. Negative 1 times a positive y is a negative y, and negative 1 times negative 14 is positive 14. Now we are ready to combine the two equations. I will write this line as our addition bar. When we combine negative 4x and negative 5x, we get negative 9x. Again, the goal when rewriting the equations was for these two to add up to 0, so we will simply cross these out to indicate that they cancel each other out. Bring down the equal sign. 13 plus 14, 27. Now we have a one-step equation for the variable x. Let's solve this by dividing both sides by negative 9 to cancel that negative 9 in front of the x, leaving us with x equal to negative 3. This is the first part of our solution. Now we are ready to take this negative 3 and substitute either into the first or second of the original equations in place of x. I will go ahead and take the first equation. The first equation is negative 4x plus y equal to 13. Let's substitute the x value of negative 3. Negative 4 times negative 3, which is our x value, plus y equals 13. Let's start simplifying by multiplying negative 4 by negative 3. The result there is positive 12. We have positive 12 plus y equals 13. Now you can quickly jump to a conclusion here. 12 plus what number is 13? Yes, 1. Or if you're showing the steps, subtract 12 on both sides of the equation, and the result again is y equal to positive 1. You can simply type for x negative 3 and for y 1. But I ask that you write your final solution as an ordered pair, the x value being negative 3 and the y value being positive 1. Again, that point represents the point of intersection if we were to graph the first and second equation. Solving a system of linear equations using elimination with multiplication and division. The goal again is to eliminate either the variable x or the variable y. If you look at the x terms, 8 and 3 do not add up to 0. And when looking at the y terms, 9 and 5 do not add up to 0. Therefore, we have to multiply these equations so that they do have coefficients that add up to 0. Let's first determine which variable we want to eliminate. When you look at 8 and 3, you have to determine what multiple they both go into. So 8 and 3 both go into 24. When you look at 9 and 5, they both go into 45. So now that we've considered their least common multiple, we want to determine which would we rather change. I usually encourage students to go with the smaller one. So in this case, we'll change the 8 and the 3 to 24s. Now, if we change them both to 24s, that won't add up to 0. Therefore, we have to make one a positive and one a negative. 8 times positive 3 will result in a positive 24, whereas 3 times a negative 8 will result in a negative 24. After you've determined this step, you're ready to write your new equations. We will write the new ones over to the right. Let's start by distributing. And recall, if you need to multiply using the calculator, especially when you have integers, to double check that. If you're still struggling there, then make sure you double check all calculations using your calculator. 3 times 8, 24x. 3 times 9, 27y. Again, if you were struggling with those integers, remember you can multiply 3 by negative 12, where the negative is the sign right next to the enter, and you get negative 36. So we get negative 36 here. Now for the second equation, negative 8 times 3, negative 24, that's not negative 24x. Negative 8 times 5y is a negative 40y, and negative 8 times negative 11, again, if you need a double check on the calculator, you can. That is positive 88. Now we are ready to combine our two equations. Let's show our addition bar. 24x minus 24x, that becomes 0x, as we planned for that. 27 minus 40, again, if you don't recall the rules, you can just go ahead and type this in. 27 minus 40, that is negative 13. But remember, the easiest way to think of that is because you have more negatives, you know you will have a negative answer. And how much bigger is 40 than 27? It is 13 bigger. So therefore that is negative 13y equal to negative 36 plus 88, since that's a positive 88. You can, again, add that directly as negative 36 plus 88 to get negative, or rather positive 52. Or you can think of it backwards as 88, a positive 88, minus 36, and that also results in 52. Now you're ready to divide. Let's cancel the negative 13 in front of the y by dividing both sides of the equation by negative 13. The result is y equal to 52 divided by negative 13. You get negative 4. We now have the y value of our solution. We are ready to find the x value. Recall from the previous example, take this y value and plug it into any of the two original equations. I will take the first equation. Actually, I will choose the second equation, noticing that the numbers are smaller than the first equation. Remember, you can use any of the two, and if you want to be absolutely sure that your answer is correct, then plug it into both and you should get the same result in both. That's how you know you have made no mistakes. We'll take this negative 4, plug it in place of the y, and start simplifying. Bring down the 3x, 5 times negative 4, that is negative 20. We now have negative 20 here, so 3x minus 20 equals negative 11. We want to cancel this negative 20 by adding 20 to both sides of the equation. To cancel that out, that leaves us with 3x equal to negative 20 plus 11, or you can read it backwards. 20 minus 11, that is 9. Now that we have 3x equals 9, you can probably already determine what x equals. 3 times what number is 9? 3. Or show the step, divided by 3, divided by 3. X is therefore equal to 3. Our x value is 3, and the y value is negative 4. Recall that I asked you to show the final solution as an ordered pair, 3, negative 4. Again, that is the point of intersection of these two equations if we were to graph them.